Hello, hi everyone. I'm extremely sorry and thank you for bearing with us. Actually, our workshop conductor trainer had problem with his laptop. Is still having that. So thank you for joining and having patience. Okay. So now I would like to introduce Upendra with you. So Upendra Singh is a blockchain developer. He's currently working at Antier as a blockchain developer. So I hope you guys will learn a lot of things about Ethereum node development uh, from Upendra. So all the best, guys, and all the best, Upendra. And I would like to hand over this workshop to Upendra now. Please, Upendra, have a good time, great time.
Hello, thank you for introducing me. Hello everyone, this is Upendra. Uh, yeah, I guess I had the problem with my laptop, but so I gonna share my screen with the laptop, and before that I'm going to introduce myself. I'm Upendra, and I'm working as a blockchain developer in the this entire, and in there I'm working on a core blockchain development. But here we are gonna uh, talk about the Ethereum and how their Ethereum node works, as I have told. So let me take you guys to the screen and let me show you what how Ethereum node works. So I guess you guys can see my screen. Yeah, if my screen is visible. Hey, Padnisil, can you tell me is my
Yes,
screen is
yes, it is visible. Yeah. Upendra, your voice is not coming, brother. Again. Hello. Your voice is not coming, Upendra.
hello.
Yeah, your voice is not coming. Now it is okay. I think
It's
you
okay,
should
right?
restart. Yeah, now it is okay.
Okay.
Yeah.
So what I have told till now, like I guess you guys have studied about the Ethereum, how it works, and how smart contract works, how Solidity works. Now I'm going to tell you how nodes or Ethereum node works, and we're gonna run our Ethereum nodes on our laptop in this class. So as you can see from this, like the uh, in our Ethereum network, we have so many nodes. Like in millions, but I have created few here. So every nodes are connected with each other, and what they basically do. So what Ethereum node basically do is it contains a transaction ledger. So they contains a transaction ledger and they communicate with each other. In through a Ethereum client, we do a transaction, and what Ethereum node do, they create a transaction and they transfer or they forward that transactions to all other nodes. They gonna they gonna add it to their blockchain, and basically our one miner is gonna add it to the blockchain, and they gonna mint the node. So I guess all you guys know this till now. What I'm gonna say here is the type of nodes and how they work, and what is the difference between them. So as I have seen shown in the screen, you can see we have four type of node. One is RQ node. RQ node is a it contains all the data in the Ethereum node from the genesis, from the starting. So this is like if you if you don't trust anyone and you want to run the whole network without trusting anyone, so you need to run RQ node because you have all the data and you can easily check is the transaction is right and everything through that node. And but as the RQ node is a full node, it is quite heavy. Like you cannot run it on your laptop. Let me show you the specification you need to run an RQ node. Uh, just a minute. Yeah. Through this website, I'm gonna show you what is the specification of laptop you need. So for Ethereum mainnet, to run a Ethereum mainnet, you need at least 12 terabyte of SSD storage. 12 terabyte of SSD storage. So that much of storage you need to run a RQ node for now, and it's gonna increase. Okay. So I guess I'm audible. Can anyone say on the chat, I'm audible or not? Okay, so let's move on the topic. So as you guys can see that RQ RQ node is a quite heavy. That's why only few nodes, only like 5 to 10% of nodes is having RQ node. But it provides us so much trustlessness. Like we don't have to trust another party. We can check any transaction through this. And let's back to the topic. And after the RQ node, we have full node. So what basically full node is? Full node is a collection, like full node don't store all the data from the genesis. Full node only store 120 nodes, 120 nodes from from the last nodes. It stores only 120 nodes, and like it crops all the and it cleans all the back, so it cleans the storage. So for running a full node, we basically need 500 GB of data. Let me show you the specification we need for the full node. And for the full node, yeah, it stores only 128 blocks of the latest blocks of the Ethereum. And in Polygon, it's 128, and you can see respected. So let me show you what is a full node. It stores full blockchain data. Yeah, it stores full blockchain data and verify all the what it do. It verify all the blocks and states. All state can be regenerated from a full node, although this will require additional state. So yeah, so like we store only 128 blocks, but through that 128 blocks we can regenerate the previous blocks, or we can connect to the RQ nodes to if you need a transaction data from the previous of full node, so we can ask it from the RQ node. So that's what it's saying. So this is a full node. And after that we have light node. Light node, what basically light node is? Light node doesn't store a full block. it stores only, yeah, it stores only half, only header of the block. So let me show you on the slide. This is our light node. This is our full node. In the full node, we have block header and full block state. But in the light node, we store only block headers. So we're gonna talk about the what is block header and what is the full body of the node in the later session. But yeah, this is the light node, and we can easily sync with the light node in like 2 to 3 hours. We can easily sync with the light node because it is quite light. It's very light. But our full node is for to sync with the full node, we easily need 6 days, 2 to 6 days to sync with the full node. And let me show you the next node. This is minor node. Minor node is basically a full node plus mining. Like a full node which also do mining activities is a minor node. Like basically all nodes don't do mining. If someone wants just features like transaction of the blockchain, so they don't uh, so they just want to check the transaction, so they don't need mining, so they don't run the mining feature on that, so that's why they call minor nodes. So basically these are the 4 nodes we have. Now let me show you the what is full node. So as you can see that this is a archive node. It contains all the blocks from the genesis, but the full node contains only 128 block. And this 128 blocks means like the blocks, like one block in the Ethereum takes easily 14 to 15 seconds. So 128 blocks will become like half an hour. So the blocks which are minted in the half an hour is just stored in the full node. And that's basically we need for to check the transactions. Like in half an hour, we can easily check all the transactions. So that's why full nodes are light. They are not that light. I guess we need easily 500 GB of SSD for that. So uh, so the fastest node is a fast sync node, and we're gonna run here the fastest node in the later session because they only store headers. So let me show you what is header. I'm gonna walk through how transaction works, and then I'll show you the header and all. So this is the uh, complete walkthrough when we make a transaction and how it gonna store on the nodes. So let me show you here. Yeah, the transaction is created using signed. So from the what we do with the using our wallets, like we do transactions through the wallet, like our MetaMask. So through the MetaMask, what we do, we make a transaction. So when we make a transaction, we use wallet to digitally sign that transaction. So our MetaMask wallet gonna sign it and make a transaction. So what actually MetaMask? MetaMask is a signer technology which sign our transactions, but in behind MetaMask is using a node. MetaMask is running its own node, so they gonna make the transaction using the node. You cannot make a transaction without using a node. You can only create a transaction if you are a client in that network. And what who is the client in that network? So basically this is a network and you are a part of network or client in a network. So one node is a client of network. So MetaMask and anyone who want to make a transaction in the network has to be the client. So MetaMask use a network or run a node. Basically, MetaMask use Infura. Infura is a node provider. There are so many node provider services. I guess you guys know. If you don't, we will learn in the later session. So there are so many node providers. They run their nodes and they provide a service. Like if you don't want to run a node, you just want check the transactions, so you can use their nodes like Alchemy and Infura. So MetaMask use Infura service to run the node. So that's what it is. So let me show you the full life cycle of a transaction. So we make a transaction using a MetaMask, and then that what our node. So MetaMask is using an Infura. MetaMask gonna sign a transaction because MetaMask is just giving a service to manage our private key. MetaMask is just managing our private key, and through the infura, MetaMask gonna broadcast that transaction. So if we made the transaction and our node, which is handled by MetaMask, is broadcasting that node, that transaction. So when we broadcast a transaction, what happens? Let me show you with a good diagram I got on the internet. So this is a diagram. What basically we do when we make a transaction, our client gonna put that transaction and broadcast it, and it's gonna land on the pool of the transaction. Every client or every node has a pool of transaction, and what transaction they gonna catch. So basically every node has a functionality to broadcast the transaction or catch the transaction. Let me show you. Yeah. So pending transaction pool. So every node has two things. One thing is a network state and other is a pool. Every node has a pool. So they store whatever transaction they catch from the network, from other clients, they gonna store it on their pool. So they are basically storing it on their pool, and this is the diagram which is showing like a pool. I have shown a diagram showing like a pool. What happens next when a minor node, not everyone can do it. We only minor node can mint a new block. So when a minor node pick that transaction, what transaction minor node pick? They pick the transaction which has paid maximum gas fee. Like when we make a transaction, we select our gas fee, like we are ready to pay for our transaction. The transaction which has maximum gas fee or more, the highest gas fee, gonna picked by the miners because they want maximum reward, and they gonna put it on a new block for and they start mining that block. So there is a tedious process, like still Ethereum is working on work from proof of work, and so they gonna do a tedious calculation of hashes, and they gonna mint the block, and the the miner the miner who wins gonna mint a block. That's a second thing. But they what they are basically doing, they are picking it from the pool. So what we have learned till now, yeah. So node verifies the transaction, add to their ledger, but unconfirmed transaction and propagate the transaction to the rest of node. So what they did, they add to their ledger and propagate to the nodes. So now that transaction is propagated to the network, and all other nodes, like maximum of nodes, have that transaction which you have created in their pool. Okay. What next? What happened next? Then what happens? Minus. So not, as I told you, not all the nodes are minus. So all the nodes in the network can propagate the transaction, can make the transaction, but only miner can add it to the network. So miner nodes gonna pick that transaction, and they're gonna put in a block. So as you can see, it is a block number 58. And before that, we have a state, we have a blockchain which has 57 blocks. Now we gonna add a 58th block. Every miner is ready to mint a 58th block. They're gonna put it on their in their block, all the transactions, because in a block there may be a different number of transactions depending on the size of the transactions. They let's one is someone has picked 50 blocks and someone has picked 70 blocks. It depends. So they gonna mint that. Yeah, so they have minted their 58th block. But to be selected as a miner who gonna attach his block on the blockchain, they have to do a tedious calculation, which is called hash calculation. So they gonna calculate the hash, and the block who wins gonna add their block on the blockchain network, and all other clients of the all other nodes gonna verify that and store it and attach it on their state, on their Ethereum state or on their blockchain. So that's a process. So let's think like your node has a like average gas fee. So maybe it has been picked by this block and this miner, but not this miner. So so for to be selected or to have a quick transaction, that's why we select and we pay highest gas fee. So if your block was not in the selected minus transaction pool or in the selected minus pool, sorry, not the pool, in the block, so that so your transaction gonna be left. It's gonna be left in the block in the transaction pool, and maybe it's gonna be picked on the other block because in every 15 minutes there gonna be a block. So this is the process. So as we have seen, miner 7 achieved the correct output and distribute the validated block to the rest of the network node. So our miner 7 got selected and he got the opportunity to attach his block to the blockchain, and now every other node gonna store or gonna their attach this block on their ledger or on their blockchain. So that's the process, and now we have a new blockchain which has 58 blocks. Before that, we have 57 blocks. Now we have 58 blocks. So that was all process. So all these things can be done with a full node. At least we need to have full node. We cannot do this or we cannot add this or validate this. Basically, a minor block is mining the block, but our full nodes are, uh, you know, verifying that block. So we cannot even verify with the which node? With the light node. With the light node, we can just read in the states and we can can verify our transactions, but we cannot verify the block because we don't have full block state. We don't have full block state. So we're gonna learn what is the block header and full block state in the later videos. Let me take you else to the next part. Till then, if anyone you have any problem, you can write it on the chat box.
Hi Upendra, I think you're not audible.
Yeah, can you
Yeah,
add me?
now you're audible. Yeah, you're audible.
No, I'm audible to you, but for everyone.
Guys, can anyone comment? Are we audible? Please comment someone. Can anyone please comment? Yeah, 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 we are audible. Upendra, please carry on. Hi, Upendra. Again, you are not audible. Upendra. Upendra. Hi, Upendra. Again, you are not audible.
Yeah, actually, I guess you have to connect me my second phone.
Now you are audible.
Yeah,
Okay?
yeah, my second
Now
device
you are
has
audible.
disconnected.
Yeah.
Yeah. So what I was saying
Okay.
that what is the difference between the front like Web 2 and Web 3? This diagram shows you what is the difference between Web 2 and Web 3. So I guess you guys know how Web 2 what in Web 2 basically happens. We have front end, we have back end, and we have storage. We have three things. Uh, Front end is the browser part, the website, the look, and everything in the website is in the front end, and back end controls what we uh, like what we need and what we doing in through that website, what queries are we making. And in the storage we store our data like Facebook, they have front end. So front end, a user can interact with the Facebook, a user can create their website and can see other person's website, sorry, not website, profile. And in the backend they manage how they gonna like complete that query. Like if you are searching a person through the our front end make a query and our backend gonna fulfill it. And if you ask a photo of a person, they gonna take that photo from the storage. So what that's all happening in the web 2. In web 3, what's happening? We also have a website in the web 3. What we call our DApp, our decentralized application. What they are doing, they have a front end, but they are using a node provider. Not all decentralized applications are using their and are making and are working on their own node. So what they do, they take a node provider. What are node providers? There are so many node providers in market right now. Mostly we use Infura. I guess if you are in Web3, they you know Infura is quite famous. QuickNode and Alchemy. Nowadays, Alchemy is quite famous. So what node provider is doing? If you cannot run your own node, it's very tedious process to manage their own node. And if a person is creating a small website or a decentralized application, like why do they need to put efforts to manage a node and creating a node and put uh, to invest so much if they have a very less less user. So what they can do, they can take a service on subscription from that node providers. They that node providers they gonna run node hardware node, and they going to provide a platform through there you can access that node. What they do, you are gonna make a transaction from your front end. They gonna they're gonna make that transaction. You're gonna call for that transaction. They're gonna make that transaction through their nodes, and they're gonna verify and add that in the blockchain. And in the down that there is a smart contract. So through the nodes, through the client node, if you have your node running in your system, what you did, you will you will deploy the smart contract through that node. But as you don't have your node, you're gonna deploy that smart contract through the node providers. So they gonna help you to deploy your smart contracts. And what after this deploying your smart contract will run on the blockchain. So through that node provider, you can also communicate with your smart contracts. What happens in the blockchain? You have an account. You, they basically create your account as a contact account. There are two type of account. Let me tell you. There are two type of accounts in a blockchain. One is for the transactions, and one is a contact account. One is a normal account, and the one is a contact account. Through the normal account, we communicate with we make transactions and all. But the contact account is that in which we deploy our smart contract. So what actually happening here? Uh, what actually happening here is we gonna. Am I audible? Like I have doubts. Padnisil, am I audible? Anyone? Okay. So what we do? We're gonna deploy a smart contract, and then now our smart contract can is running on the blockchain, and we can communicate to our smart contract through that node also. And in the lower layer, what blockchain is actually doing? So so the part of backend or the server is done by our smart contract. What data we want to access and what changes we want to save in our blockchain is gonna done by a smart contract. And as a storage, we gonna use blockchain. So we use blockchain as a storage here. So this is all how our Web3 works. Okay, guys, is it clear? If anyone can comment something. So yeah, that's all about the Web2 and Web3. So that's our Web3. Yeah. So that is how our Web3 works. I'm giving a idea how Web3 works. So let me show you a bigger picture. Yeah, this is the bigger picture of a node. Our node actually looks like that. So sorry, this is not a big picture of a node. This is a picture of our block. Since as I told you, uh, sorry, this is a block, and let's say this is a block B. We have so many blocks, and this is a block B of our smart or a blockchain. What it contains? It has block header. That it contains block.
Hi Upendra, I think you are not audible.
Yeah, guys, can you say I'm
Now
audible or
you
not?
are.
Yeah.
Yes, you are audible.
Yeah. So that's what I was saying. Like, I wanted to show you the bigger picture. The pictures you saw in the YouTube videos, they just mention a few things on the block header, but this is our real block header. I like there is a world state tree, transaction tree, and transaction receipt tree. They have all their different mean. Like world state tree make the log of your account stores the transactions and the balances, accounts and balances. The transaction tree records your transactions, all the transactions you are making, and the transaction receipt tree when your transaction happened, and like the node verifies that your transaction happened, so the information received from that is stored in the receipt tree. So this is very important, and we gonna learn in the next sessions, if we not today, in the next session, because this is a quite deep things. There are so many things happening here, like you can see the how roots are working. So I guess let's move to the coding part, or to running a node, I guess. So guys, let me take you to the our terminal. What basically we gonna run run a Ethereum node. So let me show you how it looks. Basically, I have installed everything. So if I simply put the command get, and it will start our Ethereum node. As you can see, yeah, you can see my Ethereum node is starting, and we got our IPC root here, and still we are. So guys, this is it has, and still we are using proof of work. So that's why it has, and you can see that this is a IPC endpoint. So basically, what is IPC endpoint? We How can we communicate our blockchain or our node? So if we want to communicate our node, we create account, we make transaction through this IPC endpoint. What you can see there, it's generating state snapshot, local not record, and looking for peers. So what actually happening here, our node is trying to start and looking for peers is other nodes. So by communicating with the peers, what our node is going there, it is going to copy the block. So when we start our blockchain, what is what actually our node is to do is try to copy the block and complete the blockchain. So the first thing is done by our node is copying the blockchain. And so as you can see, importing new block headers. So basically I'm running a light mode, so it's just importing a headers. And as you have seen, yeah, so syncing in process, and connecting with the peers. So this is to show you how blockchain node look like when it start running. So it start connecting with the peers, and after that it's importing block receipts and headers. So to stop our blockchain, we do Control C, and now our blockchain has stopped. So let's see from the beginning, how can we run a blockchain or a block node on our network. Let's clear it all. So for that, we're gonna use our official document of Geth. So what is Geth? Actually, Ethereum network is not providing their own client. Geth is a client which help us to manage our blockchain node or Ethereum node. Basically, it installed the functionalities, the tools to run our Ethereum node it creates the runtime environment for the Ethereum node. So there are other clients. Get client is using Go language. In there are other clients which are using C++. So in the market, the most famous is Get, and the most easiest way to your install your or run a node is Get. So we are also going to use Get, and I'm using official documentation, so you guys can easily refer. If you wanna create the node, you can go and see the commands in the documentation. So I gonna use it on the Linux, which is quite tricky. So if you are using on the Windows, it's quite easy to use it on the window. So I want to show you on the Linux because it's quite good. It runs good and compatible on the Linux. I suggest you, if you can install a partition on the Linux on your laptop, use Linux U2. So what basically commands here? It's very easy. So let me show you the easiest way to install Get on the Linux. And for before installing the Get, what we have to do, we have to create a repository, launchpad repository, and then we're gonna install Ethereum. That's simple. So before installing, I have to delete or uninstall first. So let me install that. Okay, I forgot the command. Let me see the commands. Wait a minute. Yeah. So I forgot the command. So you can check how you can check your command list and what you have installed on the Ubuntu and how can you install there. So we have to, what we have to do, we have to uninstall our package. So what basically we're gonna do, see sudo apt get remove, and we have Ethereum package installed. Yeah, and the package name, we gonna write sudo apt get remove and the package name, the package Ethereum. Hmm. Yes, removing Ethereum. And I also gonna delete all the blocks. So basically, when we have run the Ethereum node, we have downloaded some, one or two blocks. We have downloaded 2 blocks because we just started for 5 minutes. Let me first delete it. Yeah, it is deleted. So I have deleted my all the node information, and I have also uninstalled. Yeah, as you guys can see, I have also uninstalled our Ethereum from here. Now let's check if Ethereum is present or uninstalled. For that, we gonna use command apt list installed. So these are so that with that command you can check the packages installed in your all the packages installed in your PC. So basically we are moving to the E, and we don't have Ethereum here. So we don't have Ethereum here. Let's close it. Okay. So now we're gonna install Ethereum from the beginning, and we have documentation. First, we have to create repository. We'll see. So it is creating the repository for us. And the second command after that is we're gonna update. Yeah, I'm copying everything from here because we don't use this generally. So we can easily forget that we don't install nodes daily because we don't need nodes for our general uses. So you can also refer, and I'm using the official documentation, friends, because these commands may be changed in the future, but whenever the command change, the documentation gonna update really quickly. So everything you gonna get on the documentation will be up to date. So that's why I always use documentation. So basically I have copied the command for unstable, but we are not going to install unstable. We're going to the stable part. Basically what I have done, sorry, yeah, we have to copy it, that one, but I was trying to copy install unstable. So that's why I have deleted the unstable part. Let's check it, and what is saying they are installing. So it is installed on my laptop. Let me show you the packages, the other packages. Yeah, so it's installed on my laptop. So that was quite simple, right? So friends, our official Ethereum node or official get client is installed on our laptop. That's it. What we had to do, that's it. So now get is installed on our laptop. What we gonna do? Next, we gonna put simply get. To run get on or to run a node on a laptop, we simply gonna put get command and run it. But before that, I want to show you something. So let me take you in another documentation after installing get. Yeah, I'm gonna share the link with you guys. After installation, what we can do, we can simply, if we type get and run, it's gonna run the Ethereum node on our system. But if we put some extra functions, like if you wanna run a light node, because as I have told you, a full node is of 5 and requires 500 GB of data. So and high processor. So if your machine is weak and you just want to learn, see how things work, you can see it using the light mode. So we're gonna use a light sync mode here. I'm gonna show you another functionalities also. With the light sync mode, if we put a flag double dash HTTP, so what it gonna do? If we put that flag, so it will start HTTP RPC server. What basically HTTP RPC server? It allows or it starts HTTP RPC server, which helps in connect our node. It will help our node to connect through the wallets or browser extensions. Wallet, like if you are using mobile wallet, and browser extensions like our MetaMask or other custom software libraries. We use libraries of Web3.js, which is our official library. We can use through our IPC console. But if you are using other libraries like Web3 auth for to connect our wallet and to connect with other functionalities like Oracle, so for that you need a HTTP RPC server to communicate with a node. So if we want that functionalities, I guess we are not going to do all these things today, but in the next session we gonna connect with all these things. So for that we have to add HTTP flag. Okay, so we can also put a server through that we wanna connect, and if we want to run a get JavaScript console, with the console we can create the account, we can make transactions. We basically, when we use the 3JS library, we use our get our JavaScript console. So to do that, we have to attach other terminal. To attach other terminal, we use get attach command. So we can use all these things, and this is a up-to-date documentation because we are using official documentation of Ethereum organization. So now, in case you don't want to run a mainnet, Ethereum mainnet, you want to run a Ethereum testnet, because if you want to make transactions also, you can want to check how transactions are happening. You can check in on Etherscan. To do all these things, you want to do it through the test network. So you can also connect it with the testnet using a flag of that test network, like Rinkeby, Corley, because now option is not working. So the new testnet is Corley. So these all are command you can use. So let's start with the simple command get sync mode light. Let me copy that. Yeah. And that's it. As we put our command, it says I am connecting with the chain ID 1. This is a basically chain ID defines which network, which block, which Ethereum network you are connecting. If I had the chain ID 1 is for mainnet, 2 is for testnet like Rinkeby, and I think 4 is for Goerli testnet. So this is what makes a difference. Like all the testnet work similar as our blockchain, but this is the chain ID differs from mainnet and testnet. And after that, here is home street, and for DAO fork and Istanbul. These are, let me show you what are they. So basically, okay, I have to stop the blockchain because it started and it's moving up. Let me stop for a while to show you guys. Yeah. So what is this? Let me show you. It says chain ID is very important. If the chain ID is 1, which means we are using mainnet official Ethereum network, and if the chain ID is 2, which means we are working on rank B. If we had put rank B, then the chain ID for had to be 2. So the chain ID defines which network we are communicating, and the second part is consensus, which consensus we are using. So like we are using it has is a proof of work. In the mainnet we still use proof of work. Ethereum is migrating to proof of consensus, but still we are using proof of work. And if we had worked use our rinky way, it was using proof of consensus, I guess. We'll run that too and see what consensus rinky we use. After that, pre-merger hard fork. So merge shown is before merger. These are the hard fork. What is hard fork means? So basically, what happens? All the developers are suggesting their EIP, Ethereum Improvement Plan, and something. I'm forgetting the full form of EIP. Let me search. Let me search what is EIP. So Ethereum improvement proposals. So what if a developer finds some, like, as a open source, like a developer, we can also do that. If a developer, or like I'm a developer and I find some improvements we can make, like a community, I'm in the Ethereum community. We all in the Ethereum community, so we can propose some improvements to the Ethereum nodes. And what basically happens when the developers propose some changes, so they gonna read by the community, and if all the community members are agree, they gonna collect all their changes. And if all the community member agree, means the nodes, like let's see there are 10 million nodes running, and if five more than 5 million nodes are agree with that changes, they gonna take a hard fork. They gonna take a turn, or they gonna make some improvement there, and they gonna start implementing that. And this is going to be put on the community guideline. Like for if for now, after that we are using these functionalities, like we are changing our proof of work to the proof of stake. So if such decisions have been taken by the community, and all the nodes, like 50 more than 50% nodes are agree, have they started using that functionalities. So what happens, there is a hard fork. Like there are going to be few nodes, like if it's on the community, all the nodes has to update their client, and they're gonna put the same functionality. But maybe like 10% are node are still using the previous, they didn't updated their client. So what happens, they are going in the right chain, but all others are have taken a hard fork. So what basically happens, the most community are shifted to that, they have changes. Like you can see, this is a block number. What you can see on the screen, it's as you can see, the block number is 1 million. Yeah, it's we can say 11 lakh 50,000 block number. So from that block they have taken a hard fork, and that hard fork is called homestead hard fork. So that was a major change in the network. Before that, DAO hard fork and all, and we can see the latest hard fork was Gray Glacier. So this is the latest hard fork which is the latest. As you can see, the it has biggest block number. So the hard fork which has been taken from the latest block number is the latest, because it's about 15 million, and the number of block is 15 millions. And let me show you the current block number. Current. So the current block number, which has minted 24 seconds ago, let me show you on the Ether scan. So as we can see, at 26 seconds ago, we had minted our, this is the block number, and it's about 15 million. Okay. So this is a current block number, and the hard fork we were talking about. This is the hard fork. Yeah. So this is the latest hard fork. So that this is the way our improvement happens in the Ethereum. Like if you say that Ethereum is immutable and we cannot change anything in the Ethereum, we cannot update it, we can update it, but with the acceptance by community. Like if a person individually try to change the Ethereum, no one gonna accept that change, and he will make a fork, but that fork gonna be his only, he gonna mint that forks only. So that's not gonna be mainstream. So to be in the main Ethereum, the improvement proposal gonna be selected by most of the community member. So that's what they call hard fork. And if the proposal didn't accepted by the maximum supporting like majority of members, community members, majority of nodes, and only few 10% are members are taking that changes. So that's called the soft fork, because it will not work. And in the end, they're gonna attach to the main chain or main fork. So these are the hard fork happened till now. and they have given them some name with the city and all. After that, what happens? Merger not confirmed, and then this is storage. So where they gonna store our blockchain? So this is important, friend. The root where they are storing our, so they are storing our blocks where root dot Ethereum get ethas. Let me show you the folder. Where's the, yeah, if I go to the, yeah, Ubuntu and then root dot Ethereum get ethas. So these are the blocks, and as I have stopped the block, so as you can see, we don't have any block till now. When I gonna start it, we have so many blocks here. Okay, and light chain data. Yeah, this is the, we have, actually we have one block here. In the light chain data, we store blocks, and we have one block here. Let me show you another time. Yeah, text storage enabled to it has DAX. So it has cache gonna be here, and it has DAX here. And let me show you another thing. Configuration check. Yeah, IPC endpoint. This is important, friend. IPC is inter process communication. Like in our terminal, in this terminal, we are running a node. How are we gonna communicate with our node? Because the node is running continuously, we cannot type something here. We cannot create account through there. So we have, if we want to communicate that node, we want to create an account and in that node. For that, what we need to do? We have to communicate our other terminal, or from the remote, we have to communicate. And for that, what get do? Get make a file, and we call that file get IPC. Still it was not created because we have closed it very early. So I gonna start this again. Before that, let me delete this folder again. So let's start it from the beginning. I've cleared you everything. Let's quickly run it from beginning. I'm going to delete this folder, and so we don't have .ethereum folder here, and we have a command get sync mode क्या रखेंगे? We are gonna make our sync mode light, and as I run this command, it's starting again. Similar thing, chain ID, consensus, we are using proof of work, and IPC endpoint opened, and it will take quite time to start. Let's give them time. So looking for peers, what actually it's doing, it's looking for peers. What peer is another node, so it's actually locating the nodes and gonna communicate with that nodes and copy the blockchain from there. So it's starting. I think our net is quite slow. It depends on your net and the power of your laptop, how quickly it start. And if we have used full node, it takes approximately 2 to 3 days to sync completely. So let's just skip a quiet time and let me show you the folder. I guess, yeah, the Ethereum network. So the Ethereum folder has started. We have get folder, we have key storage, we have get.ipc. That was a file I was telling you. So that file we can communicate with our node. We have get folder. In the get folder, we have these things. This is a node. Basically, what we can do on our laptop, we can also run more than one node on our laptop. This is the client and light chain data. Here, friends, in the light chain data, we store our blocks. As you can see that we have only one block for now. We have copied only one block. Our node is trying to copy connect with the peer, looking to the peer, and after connecting with the peer, it's gonna copy the nodes, copy the blocks here, and in the few minutes you'll see there will be so many nodes here, and if let it be happening. So let's move to the another part. In the another part, what we do, we gonna communicate with that node. Like you can see, yeah, it got some peers, it communicated with few peers and importing new block headers. So it started importing and like it started copying our blockchain from other nodes. So what basically it is doing, let me show you. Like we have we have so many nodes in our network. Our node is communicated with everyone. It's gonna find nodes near it. So throw them through through the other nodes who have a complete copy, a complete sync node. Our node gonna communicate with it and copy the blockchain from it. So it's gonna sync complete processing, complete blocks. Like gonna start from beginning, and as we have seen, we are running on 15 million block. So let's give it quite time. Yeah, as you can see, looking for peers, as you can see, it continuously looking for peers. And when it got some peers, it start importing block headers because I have said you the light sync node only import headers. What our header is, I have shown you our header has the Merkle tree roots of our transactions. So let it start for now. Okay, let's give it some time. And for now, let me show you what is how it looks, block header, and let me search some diagram. Okay, let me search some diagram of Merkle tree or a block header or a Ethereum header. Block header. Yep. So need to add. Where's the diagram, man? Okay, open. Okay, friends. So what actually happening here? Our block is divided into two parts. One is called header, another is transaction. So in the header, we have all the information. And which information we have in the header? Let me show you. I'm not getting this. Okay, I guess it will help. Yeah. So as you can see, our block number one have two things: block header and transaction list. Let's forget what is signature and what is public key for now. We have basically two things in our block. So in block header, we have has of previous block. So like this is a block one, it don't have any has of previous block. But if we go to the block two, the basically what happens, we put all that information in a hash algorithm and it creates a hash of that complete block, and we gonna put that hash in the next block, and then we gonna we create the a hash is a encrypted form of the data. So all the data we are storing in a block like header block nonce timestamp everything we gonna put in a algorithm, and it's gonna encrypt it in the hash form, and we got a hash for our block. So we are putting the hash of previous block in this block, and in the next block we're gonna put the hash of this block. So that's why it's creating a chain. Every block is connected with the previous block, because in that block we have a hash of that previous block. It's a kind of pointer which shows like the block number, the previous block number is that, and it stores that transactions. So for yeah, so what happens through that, we create a blockchain, and what we store in the block header is hash of block number one, timestamp. Timestamp is the time at which the block is created. Let me show you what is the timestamp. Like in the Etherscan, we can see the latest block. Let me take this block. So the latest block is this, and the timestamp was 13 minutes ago. This is not a timestamp. It is saying it was minted 13 minutes ago. And yeah, so this is the timestamp of our block. So this is the timestamp of our block, and from here you can see the difficulty level for this block. So the difficulty is something as you have studied in the proof of work. If you guys have studied in the proof of work, you have studied about the difficulty. Like I don't want to continue in this session because it will take this session long. So the difficulty, basically what difficulty do, difficulty decide which miner is gonna be selected to mint the block. You know, some says that to proof of work need uh, demands more electricity and all. So that's what, because because of the difficulty to what basically happened, let me tell you what basically happens is to mint a block, a minter has to solve a algorithm or a puzzle. They have to solve a puzzle. Through that puzzle, what basically they do, they have to find a hash. They have to find a hash. And a hash should be like they gonna put every information, this block information in a algorithm, in the algorithm which gonna convert that information in a hash. So to find that hash, they cannot that has gonna be random. But to make it difficult for the minter, what our client or what our network is doing, they gonna give you a range of hash that you have to find a hash between that range. Okay, so the minter who find the hash in that range quickly gonna be the winner. So for that to find, they are continuously generating a new hash with their algorithm. They are putting the data in the algorithm, they are continuously generating the new hash, but they are not getting the hash which is required, which is demanded by the network or in the range. So to do so, for that they have to repeat the process, and while repeating the process, they have to like, to do it quickly, they have to have a good processor and good hardware, and they also use so much electricity for that. And for in the world, or in the all the miners in the Ethereum network are doing the same thing, and only one person is gonna be the winner. So that what actually happens here. So through that process, they're gonna find a hash, and the person who got it quickly gonna be the winner. And as you have listened somewhere, or if you guys know, in Ethereum, it is decided a block time. The block time is decided for like every 14 to 15 minutes. A block is created in every 14 to 15 minutes. So what actually happens, that our network algorithm gonna change the hash range. Like if the miner are using a high machine, a good machine, or a powerful machine, they gonna lower the hash range. What they gonna give, like they have given you the 10 hash for now they're gonna give you only 5 hashes, like you have to select in that minute range only. So through that algorithm they're gonna, what they actually do, they they make it in the range, or they control the time of minting of blocks. So through that it is decided that Ethereum block is minted in a small amount of, in a 14 to 15 seconds. Like it is not exact because algorithm is gonna manage the hash. So maybe one block is minted in a 3.5 seconds, and other is gonna be minted in 4.5 seconds, but in on average it takes only 14 seconds. And so, like as we have studied, our full node have to make the storage of only 128 blocks. So 128 blocks into 14. If we do into 14 or 15, we got approximately 30 minutes. That's why I told you that we have to maintain only data of only half an hour. So that what it is. So through that, I have shown you what block header contains. The important part is the hash of block one, timestamp on, and the nonce. Nonce is the value. Like if you guys have question, if you are putting the same value, same data on the cryptographic algorithm or hashing algorithm, so it's gonna create the same hash. Like if you're putting the same name, the name of your hash, if you create the name of your the hash of your name through a same cryptographic algorithm, it's gonna create the same hash again and again. That's the feature of hashing function. Otherwise uh, the hashing algorithm is not working right. So if we are putting the same data, so how can the person is getting different hashes again and again? For that, we have put nonce in our data. This is a random number selected by the minter. If he has put the value 1, he got the different hash, and if he changed the value to 2, he got a different hash. So this is the nonce, basically just used to get the for the mining process. So that's why we put nouns, because as we have listened, like if I am finding the hashing function or hashing name of or hashing my name Upendra, so it's gonna be same if I just change the last a or remove the last a to the e, and the hash of my name is gonna be completely different. So that's why nonce is used. And why has and okay, so the next thing is has of block data. So what is has of block data? What basically has of block data is the transactions or the blocks. Let me say this transaction, this block is storing 50 transactions. Let me show you one thing. Like we have reading this block and it's mined on that, and how many transactions this block have? This block have 42 transaction and 15 transaction. These are different because we have made 42 transaction through our external account. External account we have through our MetaMask, but the internal transaction, like one smart contract can communicate with the another smart contract. If you guys don't know, it is possible. We can communicate with the another smart contract using our smart contract. So these are called internal transaction. Basically, what's happening? The state, or we are storing or removing something through that transactions too. So that transactions gonna take some gas fee or change the storage. So we call that transaction too. So this block had what this block stored. Let me repeat for you guys. Let me show you what happens here. Yeah, what happened here? Our winner miner has selected transaction 1, 2, 3, 4, random transactions. So and minted the block. So what, how many transactions it had? It is saying that our latest block had 42 external transaction and 15 internal transaction, totally become 47 of 57 transactions. So there had 57 transactions. And so all the transactions are not gonna be stored in a block header. They are going to be stored in a Merkle tree. Okay, let me show you the Merkle tree. Sorry guys, I forgot to collect all these images before. Yeah, this is how a Merkle tree works. Opening tab. Just give me a few minutes. Yeah. So what happens basically? We had 58 transactions, right? In our latest block, we had 58 transactions. So these are transactions. Transaction number 1, transaction number 2, C, D. We named all the transactions. We put in a layer, in a horizontal row, or yeah, in a row. And what actually happened is we call Merkle tree also binary tree because it's gonna communicate two transactions with each other, and then there's gonna like a root like structure. As you can see that if we call this tree, and if we invert our tree, these are leaves and this is the stem or root of our tree. That's why we call the tree. So these are leaves. These are end point, or our transactions are called leaves. So this is transaction 1, transaction 2. What basically we do, we firstly, like because our transactions are immutable and secure, for that we going to create the hash of each and every transaction, right? We're gonna get the hash of the transaction. So these are hash 1, hash 2, hash 2. And then we're gonna do what we do. We're gonna connect, like we put the hashing function. Let's say this is hash 1 is a value something like 0. Uh, as you have seen the hashing function, it's in the alphanumeric form, like let me so no like as you have seen the wallet address. Have you seen your wallet address? It's a hashing function. It's a form like 0 A B C or D, like it's about 32 digits. We put one here, and then we put another hash. We connect the another hash with that. We attach that and put in the hashing function, and we got another hash called hash AB. Similarly, we do with the C and D, E and F. So what basically we doing, we are generating a root. Like if we want to read a transaction, we can connect that root and come to the transaction. But basically what we are doing, we are finding a root hash. So from the leaves, we are moving to the root by a binary tree, and similarly we get a hash of ABCD, and then a complete root. So this is the transaction. This is a root transaction hash of our block. So all the transactions gonna be rooted using the Merkle tree, and we get a hash of all the transaction called the root transaction or root hash. And we gonna put it where? We're gonna put it here, hash of blocks. So basically our block header has stored everything. Am I audible? Can anyone say, am I audible?
Yeah, you're audible. Yes, yes, you're audible.
Okay.
Hello? Yeah.
Yeah. Okay. So what basically happened? Our block header is storing every information, everything like the transaction information in the header. So that's why using the light sync mode, why what we are doing, we are using a light. As you can see, it's just importing a block header, block header, block header. By importing only the headers of all the blocks, we can verify our transactions, because in the headers we have stored, as we have seen, we have stored the root of our transaction. So a person can easily verify a transaction through that. but he can do that only. He cannot like mint the mine the node or add something in the node. A person who has this header, sorry, a person is running only light node gonna depend on the full node miner. He gonna ask about what, like, on that route. If I ask something, like I'm running a light node and I gonna ask person, please give me the information about that transaction I have done. So he cannot cannot show what's in the transaction because he just have the root of the transaction. He gonna ask to the or communicate with the main net, a person running a main node or the full node, please give me the information about this root. He gonna see give the the root of the node, so root of the transaction, and the full node person is going to provide the information. So if person cannot, if you cannot trust any other node, you have to run a full node. But if you can trust the system or the network, because as you have seen, like, this is a huge network, every person is and it's secure, you can believe on it, you can easily do you know transaction verification through the light node. And basically, not every person, only few person are using the light node. Mainly person use uh, the main users is are of full node. Maximum node are used by maximum clients are using full node. And as per archive node, not many person use archive node because they have to put so much hard disk or so much storage in it. So that's about the full node and light node. I guess you guys understand what is light node, full node now. So let me see how many, how much we have synced with. Let me open the folder, chain data. Okay, guys. Now you can see we have synced and we have downloaded so much of blocks. All these are blocks, sorry, headers of the blocks are stored in our computer. So we can easily verify the transactions. If, like, we can easily verify if the transaction happened. We cannot read the transaction, but we can easily verify if the transaction actually happened through this. We have downloaded for now 450, sorry, 475 ads. Now let me show you guys how we can communicate with this. We are running live Ethereum node on our computer, and now we're gonna find how can we communicate with it. So let me, okay, so as you can see, we are running a node on this terminal, so we cannot put commands or communicate through that terminal. And if we gonna open another terminal, let me show you. If I have opened that terminal, I have to attach this terminal to this node. Otherwise, we cannot communicate with it. And to attach this folder, what we have Git has provided us. Let me show you get.ipc. So Git has provided us a IPC file. Through this IPC file, we can attach our terminal to that node. So let me show you how can we do it. It's a simple process, and let me find the commands for that. If I can remember, the command is get attach IPC, and we're gonna find the, yeah, that's why I have told you, when in the starting it has shown the IPC route, you have to remember the IPC route. Or there a technique I use to find the IPC node. Basically, we are running it on the Ubuntu. So for after that, we have to go to the like our terminal is running on the Ubuntu. Then we have to take the root, and then we have to enter the Ethereum, and we got our get IPC file. So through this technique, you can also put the path. So what path we are taking? Root dot and dot IPC. Okay, so it was the right command, and we have entered what. Welcome to the Geth JavaScript console. So basically, Geth is providing us a JavaScript console through that we can communicate with the our node, and it has shown me the instance is that and the block, which block we are syncing right now. This is the latest block, I guess. We're gonna see it in the terminal. So let's run some command. What command we can do? Okay, let's create a account. Like we create our, what I have told you in starting. We use MetaMask to create our account. The same thing we can do here. We can create an account here. Let me show you the account first. Before that, let me show you in the folder. This is a key store. In the key store folder, we store all the account and their public and private key. What account we create, all the accounts public and private key are gonna be stored here, and it's empty for now. And when we create a new account, command is personal. So fine. What happens actually? I forget the. Let me type it again. I forgot the close the. Forget to close the parenthesis. Personal dot. So what is asking? I have to put a password. Let me put the password 123. It's not saying on the screen, but I have typed, and then when we click enter, it's say repeat the password. I'm putting it again 123, and that's it. It has created an account for me, and this is a public key. So this is the account address of, and my public key is that, and my private key will be stored. So this is my public key, guys. And let me show you in the folder, the key store. Now we have our account here. It has mentioned everything here. And let me try to open it. Okay, we cannot open it. So we have created our first account on our node, which is running on our PC. So we can run a node on our PC. To run a light node, we just need a 4 GB RAM desktop with a like 5 to 10 GB of disk space. With that space, we can run a node here, and we can create an account. Let me put some another command. Let me show you the information about it. So we're gonna put it dot. Okay, command is it the syncing. It says false. Okay, I guess Our node didn't is not synced till now. Looking for peer. Okay, we have a network problem. Okay, let me check the command first. Did I put the right command? Sing the right command. This is my cheat sheet. Let's try again. I guess Bond was right. I think we have a network problem because it says Ethereum node is. We have asked, is it syncing information? It says false. Import new block, looking for peers. Yeah, it's looking for peer. There's some problem. I think we have network issue. So that's the friend. Like you can see, like our command is working. If our node is not syncing, it says it's not syncing. And there are so many commands. Now you can, yeah. If any of you have ever run a DApp or run a smart contract using DApp, any of you have make decentralized application, or you guys have ever deploy a smart contract on the network? Any of you? Yeah, Vijay. Yeah, we can say that there are very less use of light node. There is we can That's why maximum of client use full node or they use a node service. Like if you any of you have ever created a decentralized application in a project and all, you have use Infura or Alchemy. They are full node provider. Am I audible? Can anyone confirm I'm audible or not? Anyone? Please confirm. So guys, yeah, okay, like Vijay saying, okay. So as we can see, we can do so many things. We can transfer one ether. We can transfer, yeah. Okay, thank Vijay. So we can transfer. We can send Ethereum. We can do so many put commands. There is a library of Web3. We can use so many commands so that I will share the my cheat sheet there. So we can do so many things. We can deploy smart contract through using our this terminal. Through using this terminal, we can we can deploy our smart contract and everything through this terminal. Like uh, when we basically what we do when we deploy a smart contract, we are not just sending ether, we are sending them data. So all these communication with our node has been done by has been done by using this terminal. So now let me share. If I want to start a node providing service, I want to be a node provider, what we need to do? We need to create a hardware device on which I run a powerful node, and through this terminal I can provide through the API we can provide this terminal to the users, they can using this terminal, they can create their account like our MetaMask use. Okay, so they can create their account using this terminal. So basically, when you create your account using MetaMask, what you are actually doing, you are interacting through the blockchain using a node. There is a node running behind the MetaMask. You don't have to run your own node. MetaMask is doing things for you. He's running or he's taking a client service. MetaMask is taking a client service and running a node for you. Okay, and you are taking their service, or let's say Infura, if you are going to create a dApp, decentralized application, you are going to take a service from a node provider. Like I have created dApps using the Infura or Alchemy. They are the most famous right now in the market. You are using their service, you are using their node by their terminal through this IPC. Through this IPC file, they can communicate, you can communicate with their nodes and make transactions, and they will work as a client. They will verify your transaction there. So this is actually happening behind the scene. And there are so many things, there are so advanced topics, like if you, like I have shown you, yeah, I have shown you, this is the, like this is how Merkle actually working here, and these are different states, so you can communicate like, so there are so many advanced things we can do it in other sessions. For now, it will be not right to take everything in the session, but I want to show you in the last this diagram what actually I was telling to you. So you can ask me how they are communicating with the node, how they are providing a communication. So as I have told you that through dash terminal they can communicate, but let me show you an example through a diagram. There is a Web3 J library. So what actually Ethereum developers has provided a library. Through that library, you can communicate with the, you can, they have provided the commands so that you can communicate with the, with these nodes. You can communicate your front end with the back end. And why I'm saying that, actually, what happens if I have the diagram? Let me check. Actually, I don't have the diagram here. Let me show you the diagram. I had in mind, if I have, let me open this. Yeah. Okay, fine. What actually happens, our blockchain or our node are isolated machine. They are our node which is running on in our PC. It cannot communicate with our in other any other application in our PC. To make it immutable, to make it secure for the security, the running environment or the get client which is running in our PC is designed, or the yellow paper, we call the yellow paper, the yellow paper is provided by the Ethereum developer. So the yellow paper is provided by the Ethereum developers or Ethereum community to the clients. Like the Geth is a private client and all the others clients are acting as a client, but they have to follow such some standards. So the standards are which they provide, they follow is called the yellow, is written on the yellow paper. Like the standard which blockchain or the Ethereum follow is called the white paper. All the standard or the technology is followed by the Ethereum is written on the white paper. Similar is for the clients. Clients has to follow some standard, and the client is isolated, cannot communicate with any other application in the provided in the laptop or in your node environment. They can, basically they can communicate. So that's why I have shown in the diagram real world data event, everything happening in the browser, everything happening, every game is running on your PC. They cannot, there is no connection between the blockchain. The node is has their isolate environment, they are working running in isolation, nothing can communicate with it. So how can they gonna communicate with our application, like how we gonna communicate with, they gonna communicate with our smart contract, how gonna deploy our smart contract, and how day-to-day work happen. So for that, they have given us Web3.js library. Through the Web3.js library, we can communicate using the this terminal IPC file. They have provided us an IPC file. We can, through the IPC file, we can connect a terminal, and through the Web3.js Web3.js library, we can communicate with it. So we have Web3.js library, or there are one other method. There is another method, which is a smart contract can communicate with another smart contract. So there are services like called Oracle. So what Oracle do, they put their smart contracts in the network, and through their smart contracts, they provide information to other smart contracts. So they can communicate with that process. So there are two ways. One is through Web3.js library, one have to follow the commands, the rules, and other is that. So for now, what I can wanna show you what happening here. There, this is a Web3.js library. This is our Ethereum network, our node Ethereum client. This is the network. This is our node, and this is our transactions block stored. Okay, so through this client, a person can communicate, or a decentralized application can communicate. What happens before that? We have to sign our transactions. We create our transaction. The transaction have values, the address to, and the address which we have making to the transaction. If we are putting some data or codes or smart contract, the amount of ether we are transferring, the nouns, the number of transaction of that account, the gas price, gas limit. What we create a transaction. We basically create a transaction through our wallet. Okay, through our wallet, through our MetaMask, and then through the MetaMask. MetaMask is a basically a signer. It stores our private key, and we gonna sign that transaction and then send to the client, and then client gonna verify the transaction and put it on the blockchain. So this is the method we communicate. Okay, and this is called API. So Web3 is called basically API. It puts endpoint for the outer world, and we can make the transaction using Web3 API. So as we can transfer ether using the Web3 API, we create contracts. When we create contracts, we can deploy using the Web3.js library or Web3.js API. We can make contract transaction, like ether transaction is from the external account. We can make it from the internal account, and that can be done from the Web3.js library. So this is the process we basically follow. And I guess this we are running out of time now. So if you guys have any question, any query, you can ask me here. Or I also have a YouTube channel. You can ask, like I gonna create a small videos on small concept there. You can get the concepts there. You can also ask me on the YouTube there. And yeah, that's it. If any question, put it on the comment. So we're gonna wait for 5 minutes. If anyone have question, put it on the comment.
Hi everyone. Thank you for joining our workshop on Ethereum node development. I think none of you have like questions. Okay, so let us wrap up this call. So some part is still left, I guess. You know,
Yeah, we have some left part, but that's gonna be quite advanced topics. If the
yeah.
persons, if people
So
are beginner here, I don't think. It's good idea.
I think it depends actually.
Yeah,
Will
if
like
people,
we'll have yeah we'll have
yeah,
people will watch this session later, because there are few people who might be busy, right? So let
yeah.
us let us keep this video so that they can watch and they can get benefits actually, right?
Okay, okay, okay.
Yeah, because most of the people watch later. And again, thank you Upendra, let us meet tomorrow at the same time. And guys, if you are watching this till the end, so let us meet tomorrow with the left part, and that will be the core part. So I hope you'll be there, you'll watch the video. Even if you can't watch live, so please try to watch recording a recorded video. So yeah, I think that's all from my side. So good night, sweet dreams, and become blockchain developer with cryptography and with Upendra.
Yeah, okay. Thank you for inviting me, and
Yeah, yeah,
best
man.
of luck, guys, for your journey.
Yeah. Bye.
Okay.